We've all heard comparisons like how atoms resemble solar systems and how the structure of the universe is similar to neurons in our brains. It's interesting to note that the number of stars in a galaxy, galaxies in the universe, atoms in a cell, and cells in a living being are all around the same huge number, between 10 to the power of 11 to 10 to the power of 14. About 77% of the brain is water, while about 69% of the universe is filled with dark energy. These are both passive materials that have indirect roles in their respective structures. This leads to some intriguing questions. Could we be like cells in a giant creature, but on a planetary scale that hasn't realized its existence yet? How could we even find out? It's very difficult to answer a question like this directly, because we aren't 100% certain of what consciousness and self-awareness actually are. But we are certain about a few physical things that can help us give the best answer to this question we possibly can, including the age of the universe, the duration over which various objects have been able to communicate with each other, the size of the largest gravitationally bound structures, and the number of signals exchanged between bound and unbound structures of different sizes. By conducting these calculations and comparing them with the processes observed in even the simplest brain-like structures, we can approximate an answer to the question. This approach allows us to determine whether large-scale cosmic sentient structures might exist within the universe. There is consciousness within the universe, certainly. You and I are proof of that. As human beings, we are self-aware creatures with a strong sense of what's going on around us, and we interact with each other. Some philosophers float the solipsistic notion that the self is all one can know exists, but our practical, day-to-day interaction with each other tells us otherwise. Singular or plural, there is consciousness in the universe. That much is clear. But a big question arises in our minds as we ponder the idea of consciousness. How far does it extend? Sure, we don't know what consciousness is, but we do know that the only things we're reasonably confident can think, which is the brain, have a lot of connections and send a lot of information back and forth through those connections. Even leaving aside that we don't understand consciousness, high connectivity, and rapid signaling seem conducive to thinking. That the universe is structurally similar to the brain raises the question of whether it has similar thinking capacities. It seems that both the universe and the brain engage in the reception and integration of information. In essence, the level of complexity and information processing found within our brains may manifest at both the grandest and most minuscule scales of the universe. The idea that the universe is kind of like a living thing, such as an organism or a brain, isn't new. It goes way back, at least to 500 BC, when Anaxagoras first thought of it. He was an ancient Greek philosopher who suggested that there's a smart force called nous, guiding the universe to become more organized and purposeful. Nowadays, we might think of nous as the idea of things organizing themselves. Anaxagoras' theory isn't exactly how we see things in modern science, but as we learn more about reality, it's making us think again about whether the universe might be similar to living things and the networks they create through evolution. In August 2022, theoretical physicist Sabine Hossenfelder wrote an article for Time magazine titled, "Maybe the Universe Thinks, Hear Me Out." In the article, she points out similarities between the structure of the universe and the human nervous system. Just like our nervous system, the universe has a highly interconnected and hierarchical organization. The galaxies, estimated to be around 200 billion, aren't randomly spread out, but are grouped together by gravity into clusters, which then form even larger clusters. These clusters are connected by galactic filaments, long threads of galaxies. These mammoth structures exhibit dendritic networks, much like neurons in the human brain, with vast voids punctuating the spaces between them, creating an awe-inspiring celestial web. Zooming out to see the entire cosmos, these structures resemble the connectome of the brain, which is the complete wiring diagram formed by neurons and their connections. In the brain, neurons also cluster together, forming larger groups, and are connected by axons, which transmit electrical signals across the cognitive system. Hossenfelder discusses a study by a physicist and a neuroscientist that carefully examined the similarities between the cosmic web and the connectome. They found that based on shared mathematical properties, these structures are remarkably alike. This led her to ponder whether the universe could be capable of thinking. However, having a similar structure doesn't necessarily mean the universe can think. Just like a dead brain doesn't have thoughts, the universe needs more than just its structure to think. Thinking requires neuronal signaling, where electrical messages move around the brain. But what kind of signals could the universe be sending along these galactic filaments? And could they support some form of cosmic intelligence? Yet the vastness of the universe poses challenges. Even at the speed of light, it would take billions of years for a signal to travel across the cosmos to reach our closest galaxy. Considering the immense size and expansion of the universe, it seems unlikely that any kind of cosmic-scale information processing, similar to what happens in brains, is feasible. She considered the possibility of hidden connections that could allow for faster signaling. She suggests that mechanisms like quantum entanglement or other types of non-local connections could enable longer-range computations. These phenomena suggest that particles and systems can be instantaneously linked regardless of the distance between them, as if they are intricately connected. This interconnectedness hints at a deeper level of organization within the universe, transcending the boundaries of space and time. In a section titled "Everything is Connected," she explains how a universe with non-local connections would make sense for various reasons. If these speculations hold true, the universe might be full of tiny portals connecting seemingly distant places. Physicists Fotini Markopoulou and Lee Smolin estimated that our universe could have as many as 10 to the power of 360 of such non-local connections. And since these connections are non-local, they wouldn't be affected by the universe's expansion. In comparison, the human brain has around 10 to the power of 15 connections. While highly speculative, this concept could potentially explain recent observations of mysterious synchronizations between structures on opposite sides of the universe. For instance, a study in the Astrophysical Journal from 2019 found a surprising coherence in the movements of galaxies millions of light-years apart, too distant for gravitational forces to account for. Similarly, in 2014, the European Observatory reported strange alignments in the rotations of supermassive black holes across vast distances, along with coherence among distant quasars, bright galactic cores. These findings suggest possible non-local connections between systems in different parts of the universe, and they appear too numerous to be mere coincidences. If valid, this implies that the universe could serve as a platform for the kind of large-scale computation or thinking proposed by Hossenfelder. Hossenfelder notes that, despite sounding far-fetched, the notion of an intelligent universe is consistent with our current understanding. However, she acknowledges that the theory is presently untestable, categorizing it more as philosophy than science. Yet, one may wonder if it truly lies beyond the realm of scientific inquiry. Consciousness is a fascinating but elusive phenomenon. It is difficult to specify what it is, what it does, or why it has evolved. Defining consciousness precisely is a challenging task, as it might not be limited to humans alone. It may extend to other living organisms and even non-living systems. To quote Thomas Edison, "It seems that every atom is possessed by a certain amount of primitive intelligence." This statement reflects the broad scope of consciousness, suggesting its presence in elements beyond traditional living entities. While the conventional perspective depicts consciousness as an individual and isolated occurrence, the emerging field of the Global Consciousness Project delves into the intriguing possibility of a collective or interconnected consciousness that transcends individual boundaries. This shift in focus opens avenues for exploring the broader and interconnected aspects of consciousness beyond the traditional confines of individual experience. When discussing the human brain, consciousness typically refers to the communication and firing between neurons within the brain, as well as the functions influenced by the rest of the body. However, in a broader context, consciousness can be understood simply as a recognizable experience. The basic definition of consciousness, as per the Oxford Dictionary of Psychology, describes it as the normal mental condition of the waking state of humans, characterized by the experience of perceptions, thoughts, feelings, awareness of the external world, and often in humans, but not necessarily in other animals. However, scientists lack a unified theory of consciousness, and there's much we don't understand about its nature and origins. When discussing both organic and inorganic entities, there is no consensus among scientists on which possess consciousness and which do not. Additionally, The concept of cosmic interconnectedness transcends the physical realm, implying subtle and intricate relationships beyond direct observation or measurement. Some philosophical and spiritual traditions propose the existence of deeper, non-physical connections among entities in the universe, such as a shared consciousness or a universal energy. The implications of cosmic interconnectedness for the conscious universe are profound. If we consider consciousness as an inherent aspect of the cosmos, then the interconnectedness of all things suggests a fundamental unity and interdependence of consciousness itself. One consequence of this uncertainty is that we cannot definitively assert that other organisms, or even inanimate objects, lack consciousness. While humans can relate to animals and infer some level of consciousness based on their behavior and expressions, such as in dogs and cats, we cannot dismiss the possibility of consciousness in entities like rocks, the ocean, or the night sky, just because we do not relate to them in the same way. This is where the philosophical concept of panpsychism becomes relevant. This claims consciousness is inherent in even the tiniest pieces of matter, an idea that suggests the fundamental building blocks of reality have conscious experience. Crucially, it implies consciousness could be found throughout the universe. At a very basic level, wrote the Canadian philosopher William Seeger, the world is awake. This concept challenges the conventional view that consciousness solely emerges from interactions among neurons in the brain. Proponents of panpsychism suggest that, similar to fundamental physical properties like mass and charge present in all matter, consciousness is also an inherent property of matter. They propose that consciousness exists in varying degrees, with simpler forms of matter having rudimentary or basic consciousness, while complex systems like the human brain exhibit more advanced forms. Viewing consciousness as a fundamental aspect of the universe could potentially reconcile the subjective nature of conscious experience with the objective observations of science. It's also where physics enters the picture. Some scientists have posited that the thing we think of as consciousness is made of micro-scale quantum physics events and other spooky actions at a distance, somehow fluttering inside our brains and generating conscious thoughts. In physics, researchers are exploring the idea of consciousness as a quantum effect, led by Johannes Kleiner, a mathematician and theoretical physicist at the Munich Center for Mathematical Philosophy, and Sean Tull, a mathematician at the University of Oxford. Following the example of Roger Penrose, who proposed in his 1989 book and a 2014 paper that the microprocesses in our brains could model aspects of the entire universe, Kleiner and Tull have developed the Integrated Information Theory, IIT. This theory, while abstract and highly mathematical, suggests that consciousness is pervasive but accumulates in areas where it's necessary to integrate different related systems. In IIT, consciousness, quantified as phi, is not limited to biological entities like the human brain, but is a calculable value based on the complexity of the system being studied. For example, the intricate interconnectedness of various brain functions involved in, say, forming a mental image of an apple, contributes to a high phi value. The groundbreaking aspect of IIT lies in its proposition that consciousness is not inherently biological. Instead, it's a calculable property present wherever there's sufficient complexity and integration of systems. If the human brain, with its numerous interconnected systems, can harbor consciousness, then the entire universe, with its countless interrelated components, could possess an immense amount of phi. Kleiner explains that IIT involves a complex algorithm applied to detailed mathematical descriptions of physical systems, which can determine whether a system is conscious and what it may be conscious of. According to this theory, even an isolated pair of particles interacting in space could exhibit some rudimentary form of consciousness if they interact in the correct way. So, according to IIT, the universe is indeed full of consciousness. But does it have implications for the physical part of the universe? The math of the theory says it does not. A physical system will operate independently, whether it has a conscious experience or not. One must come to the realization that everything we experience is filtered through and interpreted by our mind. Without it, the universe doesn't exist at all, or at least not without some sort of consciousness observing it. In some physics circles, the prevailing theory is some kind of proto-consciousness field. In quantum mechanics, particles exist in a state of superposition, meaning they don't have a definite shape or location until they are observed or measured. Some speculate whether this inherent uncertainty in quantum systems could be a form of proto-consciousness at work. This idea was proposed by the late scientist and philosopher John Archibald Wheeler, renowned for coining the term black hole. Wheeler suggested that every piece of matter contains a fragment of consciousness, which it absorbs from a primordial field of proto-consciousness. In his view, this proto-consciousness field imbues particles with the potential for awareness, contributing to the mysterious behavior observed in the quantum realm. He termed his theory the participatory anthropic principle, which suggests that a human observer plays a crucial role in the process. Wheeler famously stated, "We are participators in bringing into being not only the near and here but the far away and long ago." According to his view, nothing truly exists unless there is a consciousness to perceive or apprehend it. This perspective implies a deep connection between the act of observation and the manifestation of reality. Evelyn Underhill, a writer from the 20th century, recognized cosmic consciousness as a fundamental aspect of mystical experiences. In her book Mysticism, she described the awakening of transcendental consciousness as the pivotal moment in the sequence of mystic states. This awakening represents the realization of the grand scheme of things, commonly referred to as natural order. The concept that the universe resembles a brain, a neural network, or a self-organizing complex adaptive system challenges us to reconsider our comprehension of the cosmos and our place within it. If the universe is indeed a living, evolving entity, then the emergence of life and consciousness on Earth isn't merely accidental, but rather a natural outcome of a cosmic evolutionary process. This process continuously generates higher levels of organization, knowledge, and awareness. As conscious beings capable of influencing our surroundings, we are not passive bystanders, but active contributors to the universe's ongoing development toward a more interconnected and complex state. From this perspective, every conscious being, whether human, animal, or even potentially inanimate objects, is linked through a universal consciousness. This viewpoint prompts questions about individuality and the boundaries between sentient beings. If we're fundamentally connected, it implies that our thoughts, emotions, and actions may have broader consequences beyond our immediate influence. The well-being and choices of one conscious entity can resonate through the interconnected web, influencing others and the overall state of consciousness in the universe. The concept of cosmic interconnectedness also evokes awe and wonder about the universe, proposing that we are all part of something much larger and more intricate than our individual lives or the collective human experience. It encourages a holistic and compassionate perspective, underscoring the importance of understanding and nurturing relationships with other beings and the natural world. While there is scientific evidence supporting physical interconnectedness at various scales, exploring the depths of consciousness and its interconnections remains an ongoing topic of research and philosophical inquiry. It's an idea that sparks contemplation, inviting us to delve into the nature of our existence and our place within the vast cosmic maze. And as we ponder the grand symphony of existence, we discover unity in the interconnectedness of everything, blurring the distinctions between self and the universe. In the past, the prevailing view portrayed the universe as a giant clockwork during Newton's era, an engine in the age of thermodynamics, and a computer or simulation with the advent of computing technology. Now, in the era of artificial intelligence and machine learning, we liken the universe to a vast neural network. While some may be tempted to dismiss these characterizations as mere human projections that will eventually be proven wrong, I believe they reflect a progressively deeper understanding of reality as scientific knowledge grows and we uncover more about the universe's dynamics and structure. And that's it for the video. Thanks for watching. You can watch the first part of this video on your screen, and I'll see you there.